Good evening, everyone. So my name is Jiangang, and I'm the organizer for the AMC in Hong Kong and Macau. And we know that the official computation date for AMC 10 and 12 are February 1st, 2021. But due to the time difference in Asian zone, we start the computation on February 5th. So that's 2 days ago. And so today we are going to discuss, of course, the most focused part, maybe for most of you, would be the score distribution, and as well as some hard problems. So given that this year most of the computations are online, so probably you will not see the title page of the computation booklet. So here I show the booklet, and there's one thing I want to mention, that this is a very long computation. So for AMC 12, originally it is called AHSME. And if you know what is AHSME, you may try to type it on the chat channel so that I know that you know the history well. And so the AMC actually originated in 1950. So that's already has 72 years of history. And AMC 10 originated in around 2000. So we have 22 years of history as well. All right. Then let's go to the next page, which shows the score distribution of AMC 10A. And that's the online participation part. And so the higher score is, unfortunately, we don't have the full mark in Hong Kong and Macau region. The higher score is 144, which means what? Which means the top performer got one question wrong, and the average score and the median are quite close to the half of the total score, 75. And so also it's shown the 1%, 5%, and 25% percentile. Okay, so that's AMC 10A. So the next would be AMC 12A. And for AMC 12A, the average score is also similar. And I think the 1% and the 5 percentile are similar as well. So this, for AMC 12A, the higher score is 135. All right. So that are the score distribution. And the next page, we are going to discuss some cutoff scores. And what we know is, so this is not the final of the, this is only one level. So there is a next level, which is AIME. So AIME is going to happen in March. And so one thing is we now we can guess, so what could be the AMA cutoff scores for this year. And you can observe these tables, which list the award cutoff scores as well as AMA cutoff scores since the AMC started to organize locally in Hong Kong and Macau. And what you could observe is, normally if you read the AMC manual, it shows that for the AMA, so at least the top 5% will be invited in AMC 12, will be invited for AMA. So in the past, besides last year, it's all about 5%. And for AMC 10, because this AMA, the next level AMA, is a relatively challenging computations, so only about 2.5% of students in AMC 10 will be qualified for AMA. So that's why 2019 and before, the AMA cutoff scores are all between the top 1% and top 5% cutoff scores. But last year, there are more students that could attend AMA, so the score is so the participation percentage actually means it's more than 5%. We will see what will be the MA's decision this year. And I see that there are already many information floating around online about what could be the cutoff scores this year. So my expectation, and also based on whatever our scores in Hong Kong and Macau, that's probably a good average of the global score. So 1% percentile probably around is 120 something, and the top 5% score maybe slightly higher than last year, but it's only a guess. And this year we have many special situations, especially because many students attend the competitions online. That will definitely have some impact on students' performance, and we'll see whether the online, the competition will make the average higher or lower. Let's wait. And so that's the cutoff scores. And the next would be the problem difficulties. So, of course, that's also based on the statistics of the Hong Kong and the Macau participants. And you could see that although AMC 10A and 12A have about the same average scores, but it looks like the last few questions on AMC 12A are quite difficult. And also there are some difficult questions on AMC 10A, but this may not be the last 5 questions. So that's the observation. It's not that easy to so probably if you see the first question, all the AMC 10 or 12 questions are fairly easy, but it's not that easy to achieve the full mark. When I was a student, I attended, I think, the old AHSME maybe 4 times, but unfortunately, I never get a chance or luck to achieve full mark. Although, I can in the last when I was a junior or senior, I probably can be very confident to get 130 something or 140 something. Okay, so that's about the discussion of score statistics. And if you have any questions or if you have any comments, feel free to post it on the chat channel. And so that's about the first part of our session today. And so we discussed the score statistics. And the next part, we are going to do some math. And we will go, so I according to this correction percentage, I list out the 10 most difficult problems and that I want to discuss today. And averagely speaking, we know that each question will cost only 3 minutes to solve it. And my plan time for this session is 75 minutes, and the first 15 minutes we discuss about some score things, and then for the next 1 hour discuss 10 problems. So we have about 6 minutes per problem. However, and the most difficult problems could be quite difficult, and it may take more time, especially if it's right on board. So what I'm going to try to focus would be, what is the natural method, and what are the tricks that can help you to calculate things quicker. So these are the things that may help you in your future competitions. This year we still have AMC 10 and 12B in the next week, and also, of course, we have later years AMC 10. Yeah. All right. So now let's do the 10 problems. So someone asked about whether it can be conducted in Chinese. Actually, there's a parallel Chinese session already finished yesterday, and you can check the playback. And given that we have limited space on the board, so we will only list the English questions. So the first question is from AMC 12. So that question, you see, it's very long. It's already occupied the whole board, right? And so we will see. Let's read the question together and analysis to see how we find the solution and what would be the right response or the quick response once you see the question. So 5 solutions to the equation. when I see this first sentence, my first response would be what? Would be write down all the 5 solutions. And this is j equals 1, or even you may not be write down, but you keep it in mind. So how to solve these equations? Of course, there's a root formula to solve any quadratic equation. But if you do that way, that may not be the quickest way. The quickest way is you should be very familiar with what? With z squared plus 2z. What is that? That is related to z plus 1 squared plus 3. So if you have that, and then this is equal to 0, and you move plus 3 to the right side, then you get negative 3. Take square root, you get square root of 3i. I is the imaginary unit. So for these two roots, it should be negative 1 plus minus square root of 3i. So that would be the quickest way to solve the problem. And also this trick is called completing squares. That is a very important structure in dealing with the quadratic functions. And for AMC 10A, actually there's another question, which is to find the minimum value of xy minus 1 squared plus x plus 1 squared, right? So that question also needs to use a trick. It's about completing squares. Okay, for this one we do the same. So z plus 2 squared plus 2. So that is negative 2 plus minus square root of 2i. Okay, so these are the 5 points. So after you get this, you don't really need to read this line and that line. You can just forget it. Then as long as there's a key thing, there's an ellipse. So ellipse pass through the 5 points. That's it. And then the next sentence would be talking about the eccentricity, which are some kind of definition. And the definition would be what? The definition would be C over A. And then what is C? C is the distance between 2C is the distance between the two focuses. And so I think for this question it's hard. Probably it's because you haven't really learned all these the standard structure in school about ellipse. So now let me write down the basic structures, and then we move on to the next page to do some calculation. So the standard equation for ellipse would be that. So a squared x squared over a squared plus y squared over b squared equals 1. So that's the equation. And then the c squared is actually defined as a squared minus b squared. And so here, by symmetry, we may assume that a is greater than b. And then, so that is 2 key equations. Then what is the geometric meaning of it? The geometric meaning of it would be, and you draw a coordinate plane, and then it has a ellipse like that, and given that A is bigger, so these two ends would be the 2 end points. So it's kind of like a flat, it's a flat egg or a sleeping egg, right? But not a standing egg. And these are the 2 foci, and these foci are C, and so that is a definition. And the interesting thing about this ellipse is you have to remember that any point in this ellipse, the distance to the 2 foci are the same, and that distance is 2a. So the sum of the distance is 2a. So that are all the things about ellipse. I learned the ellipse when I was a high school student, but I can still remember all this because I remember them as a whole. So I have the key thing in the key image now left in my mind is this picture, and then with this picture I can get all of this. So these are the starting point. So all the green part should be something that in order to solve this question, all the green part should be something that you have already learned. And then what you need to do is then you need to, based on this knowledge, to apply to this particular situation to see how we can solve it and also how we can solve it quickly. All right. And also, there's one more thing I want to mention and remind you that, so remember that for this year's AMC, the graph paper, the blank graph papers are allowed, which means you can get a grade paper. And if you have the grade paper, it will be easy for you to draw this point on the coordinate plane. All right, so now I just left the equation there. So maybe I will just draw the coordinate plane and highlight the 5 points and then try to locate where is the ellipse. And so y is 1, y is actually, you see that I should not write this as a very symmetric because the majority part of the points are in the negative part of the coordinate plane. So maybe here is 1, right? 1, 0. Then the other is negative 1 plus minus square root 3, right? So it will be negative 1 and then negative 2. And here we have square root 3, so it's slightly higher. Square root negative 3 is like that is. So all the things, also you notice one thing, which is they are all symmetric. So given by the symmetry, so you immediately know how would be the ellipse looks like. It looks like something like that. So maybe also you could sense that the vertical axis should be somehow like that because it could be the around here, right? This could be the highest point, or maybe here. Okay, so then how to write down the formula? To write down the formula, of course, the key thing would be this such point, which is the center of the ellipse. And originally what I write is the standard where the center is 0. So for the equation, we have to write with some unknown coefficients would be x minus, maybe I name this k, square plus b square y square equals 1. So this would be the equation of the ellipse. And then what to do next? What to do next would be we have to solve it, right? Then let's see how many unknowns are there and how many equations are there. So that is the part that we need to think about, right? And so here there will be 3 unknowns, k, a, and b. And then how many conditions we have? All these things are symmetric. So because they are square things, when you put in, they only get 1. So essentially, you have 3 equations. So what are the 3 equations? Would be you plug in equals 1. So 1 minus k square over a square, because this b is 1. So that's 1. And then we have x is negative 1. So negative 1 minus k square. So if you are familiar with all the situations, what you can do is you can actually write down just as k plus 1 square over a square plus b square equals 1. And then here, remember that square root of 3. Square root of 3 take a square, so that would be 3. And then the other thing would be k plus 2 square over a square plus b square over 2 equals 1. Right? So these are the 3 equations we have. And then next, what are the strategies? So we have three unknowns, and the strategy is, and all the a squared and b squared appear very nicely, but the complicated part are the k. So, and also you see this is good, there's no b, so a natural thing to do, similar like you should treat this as a linear equation about a squared and b squared is you minus 2 on that, and you minus 3 on that, and then you take the difference, then b squared disappear. Then you get what? Then you get, after you do this, you get for some format like, and if you use this minus this, that exactly get something over a square, right, equals 1. And then something over a square equals 1, and here we have the k square. So essentially, we should be able to solve the k. So that is the root to get k. So we can get k. So once we get k, what we do? We get k, then we get a, Once we have A, we have B. Once we have B, we have C, and then you have everything. And during this kind of computation process, what you can do is you can if there are some common ratios, and actually you can get it out, because essentially what we want to calculate is the ratio C over A. So you see this question, actually there's not really some tricks involved. The first part is to solve a standard quadratic equation. The second part essentially is kind of like to solve a linear essential linear equations, but slightly simplified. Yes. Then I think the comments are quite right. So this question in a sense is not that standard. Probably that would be I think it would be relatively has some advantage for Asian students, because in our textbook we do learn ellipse and parabola and whatever, all these kind of analytic geometry to a very complicated level, and while this is seldom taught in US. Okay, so that is this question. And of course, to enhance your calculation capacity, what you have to do is you just need to do more questions, and then you would have the test to see, okay, so when you handle this kind of things, why it is a linear equations or something like that. All right, and so now let's move on to the next question. So the next question is the last question actually in AMC 12. And that question, in a sense, is also advanced, and because the definition of this function is it's kind of like some number series functions. So Dn denotes the number of positive integers that divides n, and then we define this. One, and then so they see there's a unique positive integer n such that fn is greater than all of them. And so after you read, because you probably only have 1 minute to read a question, to understand the question. So what you should get is, you should get immediately that, and this would be related to this question. So this question tells you that we need to find the maximum value essentially of fn, and to see which n that f takes a maximum value, right? So that is the idea of the definition, and hopefully, and you already know what is the formula for dn, and so that is related to the divisor, and of course it's a number theory. And for number theory, there's one theorem, and that theorem is called the fundamental theorem of arithmetic. Do you know what is that? And they say a fundamental theorem. When I first learned, I never understand why it is called the fundamental theorem. But then later on, I have more understanding about that. So, okay, so now let's write it there, maybe. So what is the fundamental theorem of algebra? So I'll just write down the key expression. So it states that for every positive integer, it can be expressed as a product of prime numbers. And if you do not care about the order, so actually the factorization is unique. In other words, it means it's a prime factorization. And the reason that makes me understand this is fundamental is that once I taught a friend kids to see how to calculate the greatest common divisor of two numbers, and then I know that they feel very difficult because of what? Because so there, we know that there's a procedure to find the greatest common divisor. What is the procedure? The procedure is you do the prime factorization for each number, and then you find the common one, then multiply together. Then that would be the greatest common divisor. However, for the students who first encounter these ideas, they will feel quite complicated in the sense that the first step you do is prime decomposition. It has nothing to do with the common divisor itself. And that is also, then I understand why it is called fundamental theorem of arithmetic. For each number theory problem, a generic thing that you should consider. So in this question, it clearly mentions about divisor. So of course, that leads you to think about prime decomposition. So for any number theory problem, you should always use you should always have the rule to think about, which is to use the prime decomposition to see whether it can give you some hint. All right, now let's back to this. So if we know the prime decomposition, of a number, then do we know how to denote the number of positive integers? Actually, we do know. What is that? And hopefully, it is one of the tools that already built up in your mind for AMC, right? So the number of factors for these positive integers are in that format because for each integer, we'll take the form of p1 to the power of something, p2 to the power of something, and that something can ranges from 0 to alpha 1, which we have how many ways to do that? Alpha 1 plus 1, then alpha 2 plus 2, and so on. Then alpha m plus 1, alpha s plus 1. Okay, so that is a formula. So then we have a nice formula for dn. And then how about that? For that, you see that we can take the cubic root as well, right? All right, and then I think now we can do our computation. What is computation? Maybe I will move to the next page. So what we have would be, remember, hopefully you still remember that decomposition. The Fn on the top, it has what? It has alpha 1 plus 1, alpha 2 plus 1, alpha s plus 1, and then on the bottom it has what? It has the cubic root of everything, and actually we can write the cubic root as what? P1 alpha 1, P2 alpha 2, P s alpha x, right? So the nice thing is on the top part we can split. Then what we can do on the bottom part we can split as well, right? Okay, and then in order to make these Fn as big as possible, what are the things that we need to pick? So you need to pick each factor to be as big as possible. If you see you add a prime factor and that prime factor is not big enough, then you should avoid it, right? And so that is a thing that then we can so by using the fundamental theorem of arithmetic, so then we can, this question I don't think is complicated because they is separated into very simple numerical calculation for each prime factors. Okay, so maybe we can start with 2, and also to determine whether this is greater than 1 or not. If it's better, because the cubic root is troublesome, it's better take a cube and see how it goes. So which means essentially what we need to check is we need to check something like that. So alpha plus 1 cubed, and then p to the alpha to see for which prime p and for which number this is greater than 1, and then we can kind of like multiply them together. And now we can start with what? Maybe we can start with prime number 2, right? And see how it goes. So 2 to the power of 1, right? 1. So 2 cubed. So that is 4. That's good. What's next? 2 squared, right? And then 3 cubed. So that's good. That's even better. 27 divided by 4 is 6 point something. And maybe we try one more. And 2 to the power of 3, and then 3 plus 1. So it is 4 to the power of 3. And so that is 64 divided by 8. Okay, so that's even better. So that's 8. Okay, so it seems that this number still increased quite large. How about that? 2 to the power of 4, and that's 5 cubed. So that is You see, that is 125 divided by 16. And so that is slightly less than 8. Of course, rigorously, you can prove that how it goes. But for now, I think we are fine to stop here. That we claim that for the prime number 2, the largest scenario would be that, right? And then we can continue to do our calculation. And for 3, 5, and 7 as well. And to find out what are the things, maybe we just do one more. So for 3, then we can quickly calculate. We can quickly calculate 3 to the power of 1, and then 1 plus 1 is 2 cubed, and 3 squared, and that is 3, and then that is actually 3. That turns out to be the largest one, because the other one, 3 is 60. 3 to the 3, and then 4 to the 3, 64, and then less than 3. Okay, so the good one would be that. And then for 5, 7, and it turns out we could only have power 1. And for when r equals 1, this is 2 to the cube, this is 8. So when p is greater than 8, there's no choices. So in the end, actually we know that this number should be 2 to the 3 times 3 squared times 5 times 7. And then you do the calculation, you get the answer. So once you use, so for this question, I think it should not be hard, but of course it's because the last question probably you don't have time to see it and have time to work on it. But essentially with the fundamental theorem of algebra, with these kind of formulas that you should have in your mind before you enter the AMC, then it's just a simple numerical comparison in my thinking. So I don't think this is that complicated. All right, so now let's move on to the next one. And the next one is really hard, as the hardest plane geometry problem, right? And it has something related to circle. And normally we know that anything related to circle, it would be complicated. All right. So first, for the plane geometry problem, we need to draw a picture. And to draw a picture to help us. So how to draw the picture? So first we can draw a sketch. And also one more thing, you know that in some years in the past, the compasses are not allowed for AMC. But this year, compasses are allowed for AMC, which means you can compass to draw nice circles, which can help you think. So semicircle has diameter AB of length 14. So normally when I draw a semicircle, I'm going to draw this way. And of course my circle is not good. And then they see there's another full circle lies tangent to AB at a point P, and intersect the semicircle at 2 points Q and R. Okay, so at 2 points Q and R. So what I can do is, okay, so maybe I draw something like that. All right. And then we can draw, so this is P, this is Q, this is R, right? Okay. And QR equals 3 square root of 3. And so you'll see, when you see 3 square root of 3, and then you'll see what's the next condition? 60 degrees. So normally, you should feel a little bit happier. Why is that? Because if you know that in the 60 degree we have some special triangles that should also in your AMC dictionary. What are the special triangles? If you have a equilateral triangle, right? And one height will cut the equilateral triangle into a special triangle which forms 60, 30, and 90-degree triangles. And the ratio of these on the top part would be 1 to 2 to square root of 3. Why is 1 to 2? Because this is just half of the one side of the equilateral, and so it has some square root 3 in it. And the area of the equilateral triangle is square root of 3 over 4 times that line squared. So that is also something that you should remember, and we are going to see a question related to that very soon. Okay, so you should feel a little bit happy. Do not that panic about plane geometry problem. And we want to find area, right? All the other things are kind of, this, in a sense, this computation problem is also hard because it's expressed in a way kind of like an AMC problem. The AMC problems, they always make the answer to be an integer between 000 to 999. So they have to express in this way, and then they calculate the sum of integers or the product of some integers. Basically, from these numbers, it can give you no hint at all. So the key questions are only these first two lines. Okay, so how to handle it? Basically, it looks like you have no clue, right? Because there's nothing, so there's a semicircle, right? If you have, there's not that too many triangles. It's only 3 straight lines, PQR. So, what to do? And for me, I do have something to start with. And that is also should be a trick that you have already learned when you deal with circles. What are the tricks? The trick is, maybe I will see 2 words. Center and radii. What does it mean? So each time you see a circle, or you see a semicircle, or you see a sector, and because the sector is quite clear, you have 2 radii that form that sector of a circle. And in other cases, what you should try to see is whether you can always locate the center and then draw the relevant useful radii, and then that can help us do the things. Okay, so then in this case, how many radii that we can draw? You know that we have this circle, the center of the semicircle, and also we have the circle of the how to maybe I write here. We have the circle of I don't know the relationship, but let's just assume it's a acute triangle. So there's a center of that small circle omega, right? These are the 2 circles that we can. These are the 2 centers that we can draw. And then once we have the 2 centers, then what we can do? We can connect all the radii. In particular, we can connect these 2. To connect the 2 centers, then what would happen? Do you remember that when you have 2 circles and the relationship between the intersecting chord would be perpendicular to the line connected by the 2 centers? So actually, we know that this can be extended, right? So this would be 90 degrees. Okay, so that's one line. Then, and that's probably the circle. This is only the radii we can draw, and maybe we can draw something else. And we can draw these radii. These are the radii of the small circles. Okay, and once you have that, then you should feel happy. Why you should feel happy? Because this is 60 degrees, right? This is 60 degrees, and then this is the center angle. The center angle should be double of that angle. And so this would be 120 degrees. And if this 120 degrees, what happens? If this is 120 degrees, then what happens is this is actually, because it's symmetric, it's It's an isosceles right triangle. These are the 30, 60, 90 special triangle. Okay, so you directly get some nice special triangle, and then immediately you can identify some lenses. What are the lenses? So this half length would be half of 3 times square root of 3. So this actually would be, so this radius, the little radius would be actually 3. So half of the, so this would be half of 3. So this vertical leg, this vertical leg would be half of 3, and this leg would be 9 over. This is square root of 3, so 2 over 3. So this would be 2 over 3, and that would be just 3, right? Because the ratio of this corresponding to that we have as a 3 over 2. Okay, so then you'll see that we can have this nicely, and then once you have this, what you can get is this is, you see, this is 3, right? Then what is the radius of what is the radius of the big circle? The radius of the big circle is 7, right? And we use the 7 minus what shall I see? Okay, so we get this is 3 over 2, and there's another thing that we can. There's some other thing that we can identify. Which one? We haven't drawn enough all the radii, and there's another radii we can draw. Which one? This one. What is that? You see, that is a 7, right? And what is that? And you know that is half of 3 square root of 3. So in a sense, you can get that, right? Okay, so we do a little calculation. So that maybe I have to put down some labels. So this would be O1, maybe this is O2, and this middle point M. So O1 M, that is square root of O1Q square minus QM square, which is what? Which is 7 square, which is 49, minus, and the square root of that divided by 4, so 4 of 27. And once you get that, actually what you get is, so you get a 2 here, and then 49 times 4 is 196. 196 minus 27 is 169, which happens to be 13 square. So this is 3. This is 13 over 2. Okay, so this is 13 over 2, and this is 3 over 2. Then what you can claim is, you can claim that this line segment here is 5. Okay, so once you claim here is 5, then do we have anything, right? It's still not, it seems that we are still not enough yet, right? And so what we do is we can connect another circle, another radius that can help us. What is another radius? Another radius would be here. Because this is tangent to, I have a relatively messy picture. This circle is tangent to that P. So this must be perpendicular, which means we have a right triangle here, which is O1, O2, and P, a right triangle. So this is 5. This we already know is 3. So we know that this is 4. So you see this picture has 3, 4, 5 special right triangle. Then once we know that this has 3, and then you see we can have this as 3 as well. Okay. Then maybe you want to see how we are trying to get the triangle, the area of the triangle, right? Still, it's good that we have some nice pictures, and but then what's next? How we can calculate the triangles, the area of the triangles? Any idea? Is anyone following up with me? It seems that I have no response. And what I'm going to do is I'm not going to probably finish all the details. I just want to see, the first part, all this kind of calculation. What we can do is nicely we just use that trick. Once you have the center, draw the center and radii, we can find many nice line segments. Then the next part we will see is how we try to find the area of it. So the area of it, there's a few ways to do it. One way to do it is you'll see that we have PQR, right? Which means we can use the laws of sine to get the area. The area would be PQ times PR times this 60 degrees. So that is one thing that we can try. And there's another thing we can try. What is the thing we can try is we can actually use some other method to see if we can deduct, from this triangle, we can deduct, we can express this as the area of, how to see it? The area of, the difference of the two areas. Okay, so maybe I'm going to switch to the next picture and quickly draw another one to explain the idea. For all the radius, again, I'm going to use the red color to denote all the radius and the radius related thing. And also I'm going to write down all the right angles. Okay. So the idea is we need to find the area of this triangle. So I'm going to extend into that one. Then what do you have? Then what you have is, so I'm only going to draw to put the label on the points that's related to us. Okay. So here is I intersect this with that. Why is that? Because there's a tangent line. There's a natural tangent line. Then maybe we can use the power of point, the kp squared equals kq times kr to try to do something, right? And now, how to calculate the area of this triangle PQR. So actually, it can be written as the difference of two areas. So the area of PQR is the area of KPR minus the area of KPQ, and then for each area we can use the laws of sine to express it as this would be KR. Okay, and then times sine alpha for each term, right? And then there's a common term, which is Kp, right? So the big area minus small area with common term Kp. So we have half times Kp times sine alpha times QR. Then, as long as we already know this, and we need to know that too. And once we know that too, and then we are fine. And how to get that too? And actually, there's another typical structure here, which is I try to use the black lines to highlight a pair of similar right triangles. This is the right one. This is the right one, and we know that this is 5, 3, and 4, right? And so you know that the other is 3 and 4, and you can not only get sine alpha, you can also get the size as well, right? So that is basically how we solve this question. Okay. Now we are a little bit running over time. There's another plane geometry problem, which is the hardest question in AMC 10A, which is not related to circles, but related to a trapezoid. And for that one, how I do is, again, I have to start to write a graph about it. So how to write it? My way to write it normally is like I first make the top base smaller and the bottom base bigger. So AB is parallel to CD, and then I try to see all the conditions. So what I see, so AB is parallel to CD, and then you see you encounter trouble. BC equals CD equals 43. That's definitely not the case. And also the next question is hard because AD is parallel to BD, right? That is not good. It's definitely not parallel. So it's perpendicular. But how to describe the two line segments? To describe the two line segments would be one is kind of the leg, and then the other is diagonal. So we have to make a leg and a diagonal have 90 degrees. So what is the best part? So what is the way to kind of shuffle the notation of the vertices? It will be that, right? And then somehow, okay, then this looks like it could be kind of like similar to right triangle. Okay, so now I'm going to do what? So I'm going to maybe shuffle the indices. So AD is parallel to BD, so ABCD, so this has to be D, this has to be A, right? Okay, then I change. Or maybe you can just quickly draw a new one. So A is here, D is here, B is here. The AB is parallel to CD. Okay, so now we have this little trapezoid. So next condition, O is the diagonal, O is the intersection of the diagonal, and P is midpoint. Okay, O is the intersection of diagonal, P is midpoint. Okay, and OP is 11. All right, so we know that this is 11. That is the part we know. And also BC equals CD equals 43. Okay, so that's good. So that two parts we know. Okay, so what we are going to calculate? We need to calculate AD. Okay, So to calculate AD, what's the natural thing to do? Each time you think about the right triangle, think about Pythagorean theorem. So it's possible to get AB. It's possible to get BD from a quick look. It does not lead to anything. However, for this question, the way that I find out the solution, the path to solve this question is I'm thinking about the midpoint and the isosceles triangle. So I link the midpoint with this isosceles triangle. That guides us to draw an auxiliary line, which is the CP. And CP must be perpendicular to BD, right? That is something for sure. And then also in the isosceles triangle, there are some standard equal angles, right? So what are the standard equal angles? This angle equals that angle, right? And also, for the angle, it's related to parallel lines. So we can use the angle condition to put here. So these two angles are also the same. Then I'm thinking about, this is the angles bisector of a triangle. So maybe we can use the ratio, the equal ratio theorem or the angle bisector theorem. But the thing is, still there are many things that we do not know. So we still need to continue. And then what to continue? Angles. And how many angles we have? Actually, we have two kind of types of angles. We have right triangle. We have equal kind of three equal angles, which should be acute angles. And then the key observation would be that. So the triangle PCB is similar to triangle DBA. What does it mean? So you see these two types of right triangles should have the same shape because they have the same pair, they have the same acute angles. And then they are similar. But once we know they're similar, we see what would be the ratio. The ratio thing is nice because this BP corresponds to this acute angle, right? And what about this? BD is acute around to this angle A. So their similarity ratio is 1 to 2. So PCB is smaller and DBA is larger. So the similarity ratio is exactly 1 to 2. Given that it's 1 to 2, so we can get lots of things. What are the lots of things? First, we can have AB. The corresponding angle for AB would be BC because that is a hypotenuse and it's twice of BC. And then we know that is 86. What else? And we know BD. And do we know BD? Yes, we know BD is twice of BP. So that's cannot get it. Then nothing. And then we know that essentially, yes, AD is twice of CP, right? And if we know CP, then we know AD. But still, we don't have it, right? So kind of like you move one step and then you get stuck again. And so the question is hard in the sense that there's another trick that you need to know. And that trick is the AMC type of trick. What does it mean is AMC type of trick? It means that, it means that, trapezoid and the two diagonal will cut the trapezoid into 4 triangles. And these 4 triangles should have the ratio, the area should have the ratio just corresponding to the ratio of the 2 bases. So it should be A square, B square, A, B, A, B, right? So if you have this, keep in mind. So for me, my next step would be, I notice that DC versus AB is 1 to 2. So I can claim that DO versus OB is 1 to 2. So DO versus OB, that is 1 to 2. Once you know that is 1 to 2, then you can do a simple fraction. So DO which OB is 1 to 2. So this is a 1/3 of it. The whole thing is 1/2. So the difference would be 1/6, right? So from OP equals 11, you could get BD as 11 actually divided by 1/6. You could get this is 66, right? So that you get AB, you get BD, and then now you can calculate AD by the Pythagorean theorem. But what is the way to calculate AD? Then that would be 86 squared minus 66 squared. Okay. So what is the quickest way to do it? Maybe you see, okay, I just do the column form to do the multiplication. No, the better way is to use formula. So you do 86 minus 66 because that gives you 20. And then you do 86 plus 66. That gives you 152. That will help you to factorize these square roots because in the end you need to get the square part out. Right? So these are the tricks. Like it's difficult in the sense that you have to link two or maybe here 3 tricks together. All right, and it seems that our pace is too slow, and we only finished 4 questions. And so next we're going to speed up a little bit to only talk about yes. And someone also mentioned a good solution for that another good solution for that problem that I see, which is nice. And for problem 5, what you do is again, what are the tricks? What are the tricks? And the tricks should be the root of unity, which means you consider the solution to the equation xn equals 1, and you know that all these solutions can be written as 1 epsilon squared up to epsilon to the power of n minus 1, where epsilon can take the format as cosine 2 pi over n plus I sine 2 pi over n. And the geometric picture of it would be that. So you draw a complex plane, similar like a coordinate plane. You draw the unit circle. So all the roots are kind of like formed evenly, spaced evenly around the circle, and they form a regular polygon. And what is this? This would be the epsilon, and then all the other roots because it has not 1. So when you multiply, it just means you add up the angles. Okay, and so then immediately you can link these. You can just so for this question, what you can start with, you just assume that n equals 7, and for that these 3 things are just the real part. These are just the real part of epsilon squared, the real part of epsilon 4th, and the real part of epsilon 6. Okay, so that is one thing. That is how you deal with the triangle the trigonometric functions related to complex numbers, and then the other basic formula will be, of course, it is just a Veta theorem. Or the other way to state it that is you should always remember that you can, once you have the root of the polynomial, you can do the factorization. And then you can link the ABC with this product and sum of these 3 numbers. Right? For example, what is x squared term? The A would be the negative cosine 2 pi over 7 minus 4 pi over 7 minus 6 pi over 7. Okay, so A would be that, and then B is the product of any 2 and then add up together. And also this is essentially the Veta theorem, right? And so once you use ABC, and you know that you can link ABC by Veta theorem, and so somehow we want to find the sum, the product of them, and then that can be back to that equation. And what that equation tells us, and for that equation, we know that we can have this x7 minus 1 equals x minus 1. Then this is x minus epsilon. And so the epsilon here. And actually another one is x minus epsilon bar, which is epsilon to the power of 6. And when that two things multiplied out, so let me first finish this. So these, for the 7 degree 1 factors, we can separate them into 3 groups. And for this group, actually, when it expand out, it's exactly this. X squared minus 2 times cosine 2 pi over 7x plus 1. So, and then the other two terms would be similar. And then once you have this, when you expand out this, whatever you want, explicitly can be given by that polynomial, and then you come back to the original polynomial px, you could get that. And of course, unfortunately, this question also have some you need you do need some calculations, so you have to be able to calculate things quick. That's problem 5. And we have another 5 problems. Maybe we quickly go over, still focus on the idea. And problem 6, I think is hard in the sense that we have parabola again, which is a plane, which is a coordinate geometry problem. So what does a parabola looks like? That's easy to draw a parabola, which means we just draw a ball. Okay, so with vertex V and focus F. So V would be kind of like the lowest point, and F would be something here. Okay. And then this is their 6 point A such that AF equals 20. And AV equals 21. And we want to find out what is FV. But of course, here we don't know the sine of it or cosine of it. Then we can use lots of cosine. So that is a hard part. However, for this question, I think it's really something that you need to know the definition of parabola. Otherwise, you cannot really start, right? And the definition of parabola is very important. And that is what? The definition of parabola says that, so you have a focus, and not only with a focus, you also have an auxiliary line. And these all by the definition of parabola, so these are all the points that have the same equal distance with my right line, as well as with that particular that focus point. And then that would be all the things. Then with that, then we would be nice, and we could have more lines to start with, right? Then this would be what? This would be 20. And what else? This would be also this point, because they have the equal distance, and that equal distance must be D, right? Okay, so we have D, 20, 21. Okay, so now what's next? So which means we need to form kind of like use. So I think it's quite clear we want to find D, and then we need to set up an equation for D. And what we should try to do is we should try to use the Pythagorean theorem to help us, right? So once we know the Pythagorean theorem, we should be fine. So how to do the Pythagorean theorem? So you just get a rectangle here. Then we have a Pythagorean theorem there, right? Then can we write down the square of all all the things? If we can, then we are fine, right? And can we? And I think the answer is yes, right? And the leg is 21 square. And what else? And this would be what? This would be just 20 minus d squared, right? And what about that? That would be this square minus that square, so it would be 20 square minus what? This is 2d minus 20. So 2d minus 20 square. And then you get an equation about d, and you solve it. You should get it. And but the question, I think this question is hard in the sense that you need to know the definition. All right. So, okay, so the next one. The next one is another complicated plane geometry problem related to areas. And the keywords here, so we have some many new keywords this time. We deal complicated things about ellipse, we deal complicated things about parabola. Now here there's the complicated things that we deal with, which is equiangular hexagon. And equiangular hexagon, what does that mean? So first, what's the definition? The definition means all the angles are the same. So this is hexagon, so altogether, what is the total angle is n minus 2 minus 180 and it's 6. So 4 minus 180, 720 divided by 6, which is 120. So that is the thing. And then you have to draw it by whatever you want, right? Okay, so A, B, C, D, E, F. A, B, C, D, E, F. And then they say A, B, C, D, and E, F form a triangle with some area. What is that triangle? The triangle is this, right? And then what you could see is immediately you see, okay, so this is 120, this is 120, so this will be 60, 60, 60. So this is actually a equilateral triangle. So that is the thing that is related to the equiangular hexagon, right? So when you extend it to form, you always form equilateral triangle. So that would be one, and then by the other way, there's the other one, right? The other one would be that, right? And then how to do the calculation? So actually, once you know that, then it's just area of the equilateral triangle. It shouldn't be hard, right? And we know that for the equilateral triangle, the area is 4 square root of 3a square, right? And how to denote that a square? Then you get it's 192 square root of 3, right? And you do a little bit of cancellation, and this is 38 minus 4. So actually, you should get that a is 4 times square root of 38, right? And similarly, you can get the other one. Right? And the other one is kind of like even better, right? As when you take the square root, you first get 4 out, so you can take the square root of that 4, then the remaining thing is 81. So then B is just 36, right? So it's very nice. Okay, and but what we want to see is they want to see the parameter of the hexagon, which have these 6 sides. So first, by symmetry, you should assume you should not use A, B, C, D, E to denote it. You'd better use what? You'd better use this one. What I'm going to use is actually I'm going to use this as S1, S2, S3, and then the other 3 sides as T1, T2, T3. And also, I assume that the sum of these S, the sum of this would be S, and then the sum of these three would be T. Why is that? Because then you can quickly see that this right triangle has a parameter which is S appear once, but T appear twice. So we could have something that S plus 2T equals what? Equals 3A. So the trick here is you consider consider as a whole. To keep the symmetry as much as possible, you consider the parameter of these two equilateral triangles to form the equation, right? And then the other similar one would be T plus 2S, right? The other would be T plus 2S equals 3B. And then you add up together what you get. You get S plus S plus 2S plus, basically you get S plus T is just A plus B, right? And then you should be able to get the answer, right? Oh, okay. So I see. Yeah, there are something that I make it, I think I made it wrong, because that would be 48. Sorry, I made a mistake here. So that is 48. So 48, and then there's another 4, so it's actually 16 square root of 3. Okay. All right. So that's problem 7, and this time is almost up, but we still have 3 questions. Maybe we just quickly go over them. And for that questions, and yes, for that question, it has the hard part is about absolute value. So what do we deal with absolute value? So it's about plus, minus. So for me, when I see this question, what I think is about symmetry. Symmetry. So we have symmetry, and then probably this symmetry also means something divided, multiplied by 4, right? Okay, so now I just consider a simple case. What the simple case is anything without the absolute value. So it's x squared plus y squared equals 3x minus 3y plus 3x plus 3y. All right, and then we do a cancellation. So it's x squared plus y squared equals 6x. And then I move it a little bit. Then it becomes x squared minus 6x plus y squared. You'll see here we have the thing about completing square again. And that's what express as x plus 3 squared minus 3 squared plus y squared equals 3 squared. Okay, so that is a circle, right? So now I start to draw that circle. And that circle means it's centered at 3, 0. 1, 2, 3. And then you have a circle like that, right? Because the radius is also 3. However, we need to see that this may not be all the circle in the region, because what are the restrictions? The restriction I have is x minus y is greater than 0, and x plus y is greater than 0. All right, so x plus, so the two equations, x plus y, so this is x minus y equals 0, and that is x plus y equals 0. So this has to be both positive, which means now we can circle a region, and that region, this has to be x minus y has to be positive. This has to be both positive. So it's this. Okay. So once you have this, I think then it becomes a primary school mathematical Olympiad problem. You just cut this kind of into a 7-inch plus isosceles right triangle, and then you quadruple everything, and you will get it. And for the geometry, it's really how you link. For the coordinate geometry, is how you sometimes use algebra, sometimes use geometry. Whichever way whichever way that is easier, then you do it. Similar like a parabola, right? So parabola, you have a geometric definition, then you also have the standard format on the parabola, like y equals x squared plus something. All right. So then this is problem 9, which is actually the last question in AMC 10A. So it's talking about 3 red chips, 3 blue chips, and 3 green chips to put in the 3x3 grid. And normally you will see many questions will be like every line has 3 different colors, every column has different colors, and if you are allowed 1 to 9, then you can construct some magic squares where the sum and the row sum, the column sum, as well as the diagonal sum are all the same. So these are the experience that we have before. And then for this question, actually the requirement is only that the same thing, the same color, the 2 chips with the same color cannot be next to each other, either horizontally or vertically. So it's a relatively weak restriction. So how to deal with that situation? And I have 2 ways, and my original way is not that good. And then later on, I think I find a new way which is better. And what the new way is till that we try to use the symmetry. So when we use the symmetry, then what would be the key cell in this picture? The key cell in this picture would be just the center. So what I do is I can assume that I just put the center with whatever 1 color, and then later on that means what? We have a 3. We have a multiply 3 in it, right? Okay, so that would be 1 symmetry. So we have a multiply 3 in it. It could be any color. So I'm going to use 1, 2, 3, and then where to put 1? So you see that the 1 cannot be here, right? 1 cannot be here, cannot be here, cannot be here, cannot be here. So there will be 2 scenarios. Either 1 is in 2 different colors. It has to be in 4 colors. And either it's in the 2 colors which are kind of like in the same row, in the same column. And here, I can put it here. And then it means, sorry, there should be still 1. Then what it means what? It means that I have a multiply 4 in here, right? Because it can be either this, or that. Okay, so this, I have a multiply 4 here. And then for this one, I can put 1. Another way would be this, right? And then this has multiply 2 here, because it could be this diagonal or could be that diagonal. Okay, so now I only need to find out next would be how many ways to place in these 2 scenarios, right? And then I'm fine. And now what's next? What's next is you have to assume that this will be 1 of the colors, right? So here I have to put this as, you have to determine this. Maybe I change a color. To consider the second one. The second one here, I assume that this is 2. But this is 2 is actually could be any of the other 2 colors. So here I have a 2, right? The same thing here. I have a 2, right? Okay. So then I put 2 here, right? And see how the things go. Right? All right. So 2 here. And then you know that we need to have 3, right? So there are 3 3s that we need to put. In here, all the things, so this is a connected 5 cells. So 3, there has to be no choice at all. You have to do like that, right? Otherwise, there's no way to fill 3. Then 2 has no choice as well. Okay, so there's no other things. Then for this part, we have 3 times 4 times 2. And now we consider this part. So this bit, you see, again, there should be 3 3s, right? So the 3 has to be here, right? So these 2 cells can only place 1 3. But these 3 cells could place 2 3s. So it has to be this one, right? And then 2 has to be here. But then for the remaining 2, it cannot be there. It must be there. And then 3 there. Okay, so finished. And so the result, the final result has to be 3 times these 2 scenarios. So this is a combination of multiplication principle and addition principle, right? So 8 plus 4. So here we are consider 2 different cases depending on the situations for the 3 ones. Okay, and then symmetry times 3. Okay, so the result is 36. Okay, so And so you see from this question, let me tell you originally what I think. Originally, what I use is I use this method. I consider what could be the first line, and I assume it's 1, 2, 3, or it could be something like 1 to 1, and then do the analysis. But it is not that quick as this. It's because if you use that method, this is symmetric. We use as much symmetry as possible in this picture. All right, so we quickly get it, and we don't really need that page. Okay, one final thing is again, this ranks number 10 according to problem difficulty. And again, for this one, it's about a quadrilateral founded by the two graphs. And from the algebra, we also think for this kind of coordinate geometry problem, we think algebra and geometry by whatever way we like. Okay, so this as a squared equals b squared. So it means what? It must mean that we can know that x plus ay must be either 2a or negative 2a. So it's good that we know that we got the equation of the two lines. Cool. And the next one is easy, right? So it has to be ax minus y equals a, and ax minus y equals negative a. Okay, cool. Now we have 4 lines. Okay, 4 lines to form a quadrilateral, and we want to find the area. And this quadrilateral must be some special one, because there will be some kind of like symmetry here. So these 2 lines have the same slope, right? So what we can describe would be these 2 lines are parallel, right? And also these 2 lines are parallel, right? Because they have the same slope. Okay, then what do we have? We know that we are going to have a parallelogram. Okay, so for parallelogram, then we already know the formula would be the base times the height. So now maybe you think, okay, we need to find the 2 intersection points and then consider what the distance. Okay, but let's do a little bit more. So this will be the base times this will be parallelogram. Now let's see the slope. What is the slope for that 2 lines? Because it's y equals kx plus something. So you can move it out. Then that would be y equals, the slope is 1 minus a with a negative sign. Well, for this one, you just move y directly to the right, and then you know the slope is a. So these 2 slopes are multiplied as a multiplication -1. So, okay, so we know that not only these are the parallelogram, these are actually rectangles. The 2 pairs of lines are perpendicular to each other. So it must be something like that. Then, for me, when I see that, I smiled. Why? Because then the area becomes there's another expression to denote the area. And this is, the area is just the distance between the 2 pairs of parallel lines. And once we have that, then it would be easy. Okay. But then you see how to find the distance. Okay, so that is the next part that I'm going to see. Although to learn mathematics as a long run, it doesn't matter that how many formulas you know. It's more like what is your capacity and what is your curiosity in mathematics. But for the competition itself, it would be better that if you know more formulas. And so for me, I remember a very nice formula in my mind, which is, if you have 2 lines like a plus b, y plus c equals 0, and ax plus by plus c2 equals 0, so these would be 2 parallel lines because they're the same slope. I know the formula that the distance between the 2 lines are c1 minus c2 squared, c1 minus c2 absolute value, then takes the square root of the sum of the squares of the 2 coefficients. So this is something that is in my mind for maybe more than 30 years after I first learned it. I remember it because it's so simple, right? And if I remember that, and then we can quickly go back, right? So how to find the distance? So we take the difference of these 2. So that would be 4a. And then we take the square root of 1 plus a squared, so that a squared plus 1. And then the other one is a minus 2 is 2a, and then square root a squared plus 1. Okay, so in the final step, be careful. Of course, the bottom one will become a squared plus 1, but don't forget on the top one, there are two a's, so you should select D, but not E, and that is 8a squared over a squared plus 1. That is how you can solve this question quickly, probably within 3 minutes, and then you save some time for other problems. All right, I think that's finished. We use about 75 minutes to finish 10 questions. You'll see that's still too many. It's too long, right? However, in the real computation, you only have 3 minutes. Even like you can solve the easy questions in 1 minute or 2 minutes. If you really found the hard one, probably you have to finish, within 6 minutes, something like that. Which means in order to improve your scores in AMC computation, you really need to practice more and build up your calculation capacities. All right, so it's already very late, and good night, and we will do the same thing for AMC B version, and so see you in about a week time. Bye-bye.